So now I would like to look at least one or two more problems to see why these rational functions are so important. So I can print this out. Let me print just this page. But I would like you to open on page 428. 428. And I'm also going to print it out. Page 428, we would like to look at a couple of applications. And my printer is awake now. So I would like to look at problems 101 and 102. These are typical, very important type of modeling situations. And you may not be able to see this, but I'm going to graph it. I'm going to copy the graph real quick so you see it. So in 101, here's the graph. We're not going to read from my graph. Okay. And the function is given to us, and we're going to read the text in a second. Oh, I forgot again one thing. We need to determine, again, I'm not going to ask you to graph this, but I need to determine the max and the min here. So we already have the graph in the graphing calculator. I can zoom 6 and I see the graph. Careful, it's very deceiving. You know that this is not correct. Be very careful. I'm not going to ask you to do that, but this is the correct graph. But now without calculus, we cannot determine max min, but with the calculator we can. So I'm going to determine this maximum, and I see it's to the left or -2, so I'm going to say second and calc, and I want max, and I want max at -4, but I want to know, I don't want it at -4. Apparently it's probably further to the left. Yes, enter. I make sure that I pass the maximum. I say enter again, and it will give me the maximum. So the coordinates of the maximum are -3.9, -3.9, comma, -7.87. And now I have to also determine the minimum to complete the graph. Oops, second and calc. I want minimum now. And I know it's somewhere above 2. So I'm going to say between 1. Let's see if 1... no, it's probably exactly at 1. So I have to make sure, I'm going to say 0.5. Okay. And then I make sure it passes the minimum. And I got 0.9. So 0.92, comma, 0.66. And those should be in the table right here as -3.9, -7.87, and 0.92, 0.66. So min, of course, local min, and this is local max. Okay. Good, so coming back to our problem in 101, page 428. It says the pH level, so this function gives the pH level, 6.5 x squared minus 20.4 x plus 234 over x squared plus 36. So this is the pH level. No measurement unit for it. And x is in minutes. Minutes. And it says minutes after a person eats food containing sugar. The graph of this function is shown. This is the pH level, what happens to it. So when I look at this graph, I see, okay, we swallow something with sugar, the pH level drops within 6 minutes to this value, which I see is roughly about 4.8. And after those 6 minutes, if we don't continue eating sugar, it will come back and level off as time goes by. So the first question, use the graph to obtain a reasonable estimate to the nearest tenth of the pH level of the human mouth 42 minutes after a person eats food with sugar. So here's 42. I will say roughly 6. So from the graph, they want us to find F of 42. It appears to be 6, no measurement unit for the pH level. Part B. After eating sugar, when is the pH level the lowest? Right. We already know it. I put it in here. So the lowest is in 6 minutes. In part B, in 6 minutes is the lowest. And determine it. We already said that F of 6 appears to be 4.8. According to the graph, what is the normal pH level of the human mouth? What would you say the normal pH level would be looking at the graph or at this graph?
6.5.
6.5, yes. It's obviously where I see what's happening, right? So normal y equals 6.5 obviously is the horizontal asymptote. How do I know? Same degree over same degree. This is type 1. So it's 6.5 over 1. No question there. Part D, what is the equation of the horizontal asymptote? And part E, use the graph to describe what happens to the pH level. We already did. We swallow something with sugar. One time, the pH level drops to 4.8 from 6.5 from the normal down in 6 minutes, and then it takes a long time to level off. Also, I would like to look at 102. And here's the graph for 102, and we have the function, and you'll tell me what type of function is this? I think it's 5, isn't it? Is it 5? I think it's 5x over 5t. No, it's x. My glasses are too strong and the distance is too short. Okay. So use the graph to obtain a reasonable estimate of the drug's concentration after 3 hours. So 1, 2, 3, I would say, difficult to read from here, of course. I would say 1.5. So when x is 3, it appears that y is 1.5. Can anyone tell us what type of a rational function is this? Is it type 1, is it type 2, or is it type 3?
Type 2.
Indeed. Type 2. Furthermore, I know exactly why. I don't even have to look here, right? But yes, there are other functions. So obviously, because the horizontal asymptote is 0. That's always the case for type 2. Okay, in part B, use the functions equation displayed in the voice balloon, where here we have it, to determine the drug's concentration after 3 hours. So F of 3 will be 5 times 3, 15, 9 plus 1, 10, 1.5. And the measurement unit. So this is the concentration. So they say milligrams per liter. Milligrams per liter. Okay. Use the functions equation to find the horizontal asymptote. We already did. Piece of cake. We knew it was type 2, so the horizontal asymptote has to be 0. Any questions? Any questions? So they don't, I wouldn't say that they are easy, but once you get used to them, they're not that difficult. But it is the most difficult function that we are looking at this class. Okay, the last thing that I was going to look at is two more types of inequalities: polynomial and rational inequalities. So, you know, the first 2 pages that I torture you with all the time, now I can say we have 5. I'm adding 2 more types of inequalities. Okay. So let's start with polynomial. I will choose this time myself, and then on Thursday you will choose. I will choose 2 very simple situations because I know we have 10 minutes left and I want you to work on, there is a very simple quiz, 1 question. And rational. So I'm going to choose 2 very simple examples. Here it is. X times x minus 1 times negative x plus 2 less than or equal to 0. And as a rational, I'm going to say x minus 1 over negative x plus 3 greater than 0. They are completely separate. Don't get confused. I just wanted to put the example there, but it's not connected to anything. Because this is a product, and because this is 0, I would use a little table that I highly recommend. It's up to you. You can use other methods. X is the variable in the problem. It's not this X, it's not any of this, just the variable. And the variable can be anything. The first row is the first factor in the problem. The second row is the next factor in the problem. The next row is the next factor in the problem. And the last one is the whole thing. Product. Whole thing. I don't have enough room. I should write X. Let me write it so there is no confusion. Okay. So up here, I need 1 number for each, wherever each and every one is 0. Well, obviously, I know that this is 0 at 0. I know that this is 0 at 1. And I know that this is 0 at 2. These are my numbers in the correct ascending order. Then I'm going to write 0 under those numbers correspondingly. 0 for the first one. 0 under 1 for this one, where it is 0. And 0 under this, where it is 0. Now, for 0, the product will be 0. Because if this is 0, 0 times anything will be 0. Under 1, I write also 0. Why? Because if this is 0, 0 times x negative x plus 2 is still 0. And also under 2, if this is 0, the whole product is 0. And now what I learned and I know already, x looks like this. And I think Samantha said, oh, it's clear. It's coming from negative infinity going to positive infinity. Negative to positive. I look at x minus 1, it's still like this. Positive leading coefficient. So it's still coming from negative infinity to positive infinity. But now, this one is like this. From positive infinity to negative infinity. Okay. Or you just plug in numbers. On the first subinterval, the first factor is negative, the second factor is negative, and the third factor is positive. Okay, so it's positive. On the next subinterval, the first factor is positive, the second factor is negative, but the third is positive. But one negative spoils it for everybody. Now here they're all positive, no problem. And here I have one negative. Only now I'm asking myself, what am I looking for? Something that creates the product to be negative, less than or equal to 0. Between 0 and 1, and negative again between 2 and infinity. And it's done. So I would say x in the interval, because of the equal symbol, I will put a bracket at 0, a bracket at 1, and union a bracket at 2, infinity without a bracket, of course. This is how we solve a polynomial inequality. It's not the only way, but I think it's the most picture-friendly, if you want, type of solution. But it's up to you. There are other methods. Okay, in the same way, this is a ratio, and this is 0. Otherwise, the table doesn't work. I have to have a product and 0, or a ratio and 0. Otherwise, the table is not working. It's not applicable. So this is easier because I only have two factors, x minus 1 and negative x plus 3. And of course, the ratio, but I have room now, x minus 1 over negative x plus 3. Okay. So in the table again, I put those numbers that make each 0. It happens to be 1 and 3. Like before, I put the 0 correspondingly. Like before, when x is 1, the numerator is 0. But when the denominator is 0, I'm in trouble. I cannot put a number in there. Same thing, positive leading coefficient, negative leading coefficient. A negative divided by a positive, two positives divided, a positive divided by a negative. So now what do I want to find? X values that make this expression to be positive. Right here, which is this. So then x in the interval, I cannot choose 1 because I don't have equal symbol, and I can never choose 3 because it's undefined. And this is the way we solve